In this example, we are going to find the area of the region enclosed by the curves y is equal to x cubed minus 2x squared plus 1, and y is equal to x squared minus 2x plus 1. So we have a cubic function and a quadratic function. The first thing that we're going to do is find the points where these two curves intersect. To do that, we are going to have to set the two curves equal to each other. This gives us x cubed minus 2x squared plus 1 is equal to x squared minus 2x plus 1. Let's go ahead and let's pull everything over to the left. We have x cubed minus 2x squared plus 1 minus x squared plus 2x minus 1 is equal to 0. Our 1's are going to cancel out, and we have x cubed minus 3x squared plus 2x is equal to 0. Notice that x is common to all three terms, so we can factor that out. And this leaves us with x squared minus 3x plus 2 is equal to 0. We can factor our quadratic as x minus 1 and x minus 2. And this gives us that x is equal to 0, 1, and 2. Now we need to find the y value that corresponds to these x values. To do that, we have to pick one of our curves. I'm going to choose the quadratic one because it's easier. So let's write down y is equal to x squared minus 2x plus 1. When x is equal to 0, y is equal to 1, and this gives us the point 0, 1. When x is equal to 1, we have 1 plus 1 minus 2, so y is equal to 0, and we have the point 1, 0. And then lastly, when x is equal to 2, we have 4 minus 4 plus 1, so y is equal to 1, and this gives us the point 2, 1. Let's go ahead and let's highlight these because these are our intersection points. Step 2 is to graph the region. Since one of our curves is a cubic, it's a little difficult to graph, so I went ahead and graphed both of these curves on Desmos. That's a great free online graphing calculator if you ever need to make a graph. Let's go ahead and let's label our intersection points. These are the points 0, 1, 1, 0, and 2, 1. We'll write that down. This is 0, 1. This point is 1, 0. And this point is 2, 1. Notice that the area between these two curves is broken up into two regions. Here's our first region, and here is our second region. Now we need to choose the correct formula to use. We need to decide if we want to integrate with respect to x or respect to y. To decide that, all you have to do is go up to your graph and draw a vertical line for integrating with respect to x. If we do that, we can see that we have one curve on the top and one curve on the bottom. It doesn't matter that the curves switch, and a different one is on the top in each region. If we want to integrate with respect to y, we draw a horizontal line, but notice in our pink region, if we draw a horizontal line at the bottom, we have the same curve on the right and on the left. So we definitely want to integrate with respect to x. Our formula then is going to be our area is the integral from a to b of our curve on the top minus our curve on the bottom times dx. Now let's go ahead and set up our integral. We are going to have two integrals because with the yellow region, our cubic is on the top, and with our pink region, our quadratic is on the top. Our area then is going to look like this. Our yellow region is going to be the integral from 0 to 1. The curve on the top is the cubic, and that is x cubed minus 2x squared plus 1. And then we're going to subtract off our quadratic, which is x squared minus 2x plus 1 dx, plus our second integral, which is going to go from 1 to 2. The curve on the top is the quadratic, so this is x squared minus 2x plus 1, minus our curve on the bottom, which is x cubed minus 2x squared plus 1, times dx. Let's go ahead and let's simplify each integral. Our first integral is the integral from 0 to 1. We have x cubed, and then we have a minus 2x squared minus x squared, so we have minus 3x squared. And then we have a plus 2x, and our 1's cancel, so that's nice. So that's just dx. And then our second integral is from 1 to 2. We have minus x cubed. We have a 2x squared and an x squared, so this is plus 3x squared. And then we have a minus 2x, and the 1's cancel. And there's our dx. We are not going to have enough space to evaluate this integral on this page, so I'm going to go ahead and I'm going to grab it and take it to the next page. Now we can do our integration. Let's integrate our first integral. This is x to the 4th over 4 minus 3x cubed over 3 plus x squared, evaluated from 0 to 1, plus, with our next integral, we have minus x to the 4th over 4 plus 3x cubed over 3 minus x squared. And we're going to evaluate this one from 1 to 2. This gives us 1/4 minus 1 plus 1. And then for our next one, we have minus 2 to the 4th over 4 plus 2 cubed minus 2 squared. And then we're going to subtract off minus 1/4 plus 1 minus 1. It's really important to write it like this so that you don't forget to multiply this negative through to all three terms. Now let's see what we get. This is 1/4 minus 2 to the 4th. That is 16, and we divide that by 4. So this is minus 4. And then we have a plus 8 minus 4. And then we have a plus 1/4. All three of these terms cancel out. We have a minus 8 plus 8, so we just have 1/4 plus 1/4, which gives us 1/2. The areas between our two curves are equal to 1/2.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.